second part of the experiment. Now we want to try to extract the alcohol from the water. And so we have our mixture here, and what we're going to do is we're going to use the difference in boiling points between these two liquids to be able to separate them. So I want to be able to heat them up, go into the vapor state, but then be able to collect that vapor. So what we're going to set up here is a fractional distillation. And so we have a flask that we are going to do our boiling in. So we're going to transfer our liquid to this material, or to this flask. And we need to be able to heat that up, so we're going to use a thermal well. This is a ceramic heater. You can see that it fits this very tightly, heats it up all around. We tend to use a round bottom flask because it boils a little bit better. We have the ground glass joint here. And then this has a power supply to be able to control the temperature there. So it's a little different than our hot plates. We just control the amount of voltage that's going through. So we need to be able to have our column where we do the fractional distillation. Then we need to have a condenser to collect it. So we're going to start assembling it here. All right, so what I've got is I have my ground glass, or my column here. It's got ground glass joints, and it has, this one has metal wire in it. This is to create all of the plates, the places for the vapor to condense and then re-vaporize. All right, so we're going to start by clamping that. You want to be careful and clamp all of this glassware. This glassware is very expensive with that. Now we're actually going to set the thermal well up onto a ring stand and suspend this whole thing up in the air. Now, why would we do that? Well, while we're heating this, in case the temperature starts getting too high, we want to be able to remove it from the heat. Now, if I just set this thermal well on the ground, then I'd have to lift up my entire apparatus to do that. But if I do it this way, then I can just drop the thermal well out if I need to, and we can go from there. Okay? So that looks like a good height here. So I have my column. So now what I need to do is my vapor's going to come up. I want to have it move over to my condenser. So I've got this joint here. But we also want to be able to measure the temperature. So the vapor is going to come up, and then we're going to start condensing it out that way. So we have a thermometer adapter here. It has a rubber tube, rubber connector on top. And we want to put this in. Now you want to be really careful when you do this. It's kind of a hard rubber. And if you hold the thermometer out here, you're probably going to snap it. So you want to make sure that you're holding it down near the stopper, and you just do that very carefully. Okay? And so we're going to put this in. We want the thermometer bulb to be about where the condensation is going to occur. So right about where this end joint is here. All right? So we're going to measure, because we've got temperature data that we need to collect as we go. Okay, now you can see that this is kind of loose here. I'd rather it be a little more stable. So we have these Keck clips. They're a blue plastic. They come in different sizes that are different colors. They have a larger side and a smaller side, and it can connect between the two of these and then hold these joints together. Pretty nifty. Okay. Next, we need our condenser, and this is going to go on here. We also clip this. Okay. And connect that. Now, I don't want to just rely on the Keck clips. I prefer to brace this as well, so we're going to use another clamp here. I'm using these 3-prong clamps. Open that up. Okay. And we're not quite tall enough on this ring stand, so we're going to see if I can get this to go. Okay. There we go. Right at the top. All right, so we're going to have our vapor come up. Now it's going to go into here. And right now this would be air-cooled, which will cool it some, but not necessarily fast enough, and our vapor could escape. So we're going to actually use a water-cooled condenser. So I've got some rubber hoses here, and I'm going to connect it to my water supply over here. Actually, we're going to use the blue water supply today. We need to think about where we're going to attach this. So we have two options. We can attach it at the top of the condenser or the bottom of the condenser. The problem is if we attach it at the top of the condenser, the water can flow right down here to the bottom and then come out. It doesn't necessarily fill the entire container. However, if we connect it at the bottom, then gravity will help fill the entire jacket, the sleeve, and really cool this down, and that will work better for us. Okay? And so then we need to collect the water that comes out. Now, another thing that we just need to be careful of here is that we want to make sure that these tubes don't touch the thermal well, or they will melt. Now, it only takes a little bit of water to do this. Okay, so my valve's down here. Show you what I got here. So I can now turn this on very gently. takes it a moment to get going. Okay, there we go. We got water coming up. And see, it fills it in completely, and then it just drains out the back. I'm going to run this tube up here so it doesn't get melted. Okay? So now we're condensing our gas that comes out, but we need a way to collect it. All right, so we have another piece here that we're going to use. Okay? That is going to cause our liquid to drop down. And if you'll notice, the end of this tube, end of this connector here, has a very small tube that's going to allow us to drip into whatever collection flask we want. Now you could, as you see there is a hose barb on here, you can actually also put this under vacuum. We're not going to, we're just going to be collecting it today. And what we're going to do is we're going to collect in graduated cylinders, and we're going to use those because they're going to allow us to measure our volume, because we want to know the density of the material that's coming off here. So you can probably see on the back window there, I have pre-weighed 10 of these. We shouldn't necessarily need all 10, but I wanted to have extra just in case. Okay, I'm going to use this to hold my graduated cylinders in place. Okay, so we got quite a setup here. Let's get our first grad cylinder on there. All right. Now, normally during the lab, we don't have enough graduated cylinders for everybody to have 10, and so we'd swap them out every once in a while. You'd have 2 that you'd be working with your lab partner with. Okay, so we have the general setup now. We're going to put our liquid down here. It's going to boil. It's going to condense. Some of it's going to slide down here. We're going to start collecting it down here, and we can measure our volumes as they come off. As the run goes, we want to know the volume of the material that we collect and also the temperature. So we're going to be measuring multiple or gathering multiple data points as we go. Okay, so now let's transfer. I've got all this secured so I can lower this down, okay, as I talked about. And we want to transfer this. I'm going to go ahead and put a couple boiling stones in here. Probably don't need it for this one, but anytime I'm boiling, I like to use that. And then I've got a funnel here. Okay, so let's go ahead and do our transfer. Careful with this. Okay. And can I let it sit in here? Nope, not going to sit in there. I'm trying to think of a way to do this where I don't actually spill into the thermal well. Okay, transferred all of that. Okay. All right. Smells like yeast. Baking bread. Okay, so now let's lift this up. We want to make sure we get a good seal on here. Slides down. This is a place where having a lab partner is actually very useful. Okay, so we want to check it before we ever apply heat to the system. I've got a good seal here. I've got my fractional column. I'm connected here. I have my thermometer sealed at the top. You can go down here. I've got my water running. I have something to collect it in. This is also sealed. Looks like we're ready. Okay. So the little power mic here plugs into the wall. It's actually just a rheostat, a variable resistance device here. Plug this in. Now, it's not exact on this. The scale on this just goes from 0 to 100. That's 100% of the power. We're actually going to start at about 70% here.